So it's time. Hello, everyone. It's time. So let's get started. Good morning, good afternoon, good evening, everyone. My name is Qiu Fang, and we have my co-chair, Daniela. We are hosting this meeting together. So please be aware that this session is being recorded. So you should be familiar with the note well. This is a reminder that by participating in the IETF, you agree to follow IETF processes and policies. If you don't know this well, please take a look at this slide, and even better, look at a couple of BCP documents given in this slide. For IETF conduct guidelines, the IESG has asked all chairs to remind their working group of the need for appropriate behavior. Please, let's be respectful to your colleagues. Please be kind and make your comments impersonal. Let's focus on the technical discussion. This is IETF 119 meeting tips for both the in-person and remote participants. Please use the mid-echo queue control to join the queue and make a comment. Please be aware to identify yourself and keep your audio and the video off if you are not an active speaker. And this is about the mid-echo information guide. There is some materials and some participant view of controls and tabs. Please be familiar with the mid-echo new interface. And for minute takers, we do need some volunteers to help us take the minutes. Please help us, and only the discussion needs to be captured. So today we will have 2-hour session, and these are some links of the meeting materials. So here is our agenda today. After the chair's presentation, our new AD Maharsh is going to say something to the working group and maybe to Rob as well. And then we'll followed by Todd to present a young data model for network inventory. This is our the only one working group item that has been adopted since last IETF meeting, and then followed by Nigel and Italo to lead the discussion of IV boundary and terminology. So there was a side meeting about this related discussion happened on Monday this week, and they will present some outcome of this discussion. And then we will have Bo Wu to present a network inventory location module, and then followed by Diego to present the asset lifecycle management and operations. And finally, we will have Tim to present a young data module for energy 7 management. Okay, any agenda question before my co-chair take control to present the working group status? All right.
Okay, so briefly, working group status update. Since the last meeting, we have our first working group document. The core model was adopted. There was, I mean, a pretty, I would say, a pretty good support. Most of the working group was happy with the work done so far. We had a couple of side meetings during the week. One of them was focused on scoping. If you remember, we had raised this issue about IV boundaries. What is inventory? What do we need to focus on, etc. So you will see in a minute a proposal on how to reduce the scope of the core model, so to allow us to deliver something on time to be used by the industry, by the community. We are having weekly calls dedicated to the inventory core model. Every week on Wednesday. They have been interrupted because of the meeting, but we will start again immediately after. Again, if someone is interested to use IV resources for meetings dedicated to any other draft, feel free to reach out to us to request for it. Liaison and communications. So we have an incoming liaison from BBF. They started a new project entitled NRM, Network Resource Model. Basically, they are asking us a few questions. We had another side meeting with people from the Ivy working group, people from the BBF, to use some face-to-face time to clarify what the request was. So we now better understood the context and the request to us. So after the meeting, we will ask on the mailing list to contribute to a reply to the liaison. We will draft some text. Everyone is invited to contribute to that, and we will send a formal liaison back. If we will not succeed to put together a good reply on the mailing list, we will call for an interim meeting where we can further discuss what is needed. That's it from our side. I think we are ready to start with the first presentation. Before that, I would like to invite Mahesh to say a few words as our new incoming AD.
Well, okay. On that, I'm still not quite the new incoming AD. Rob is still the AD for this meeting. But I did want to take the opportunity to thank him for his time. He's one of the few ADs that I know would come to a meeting and actually start taking meeting notes. I don't know of any AD who's capable of taking notes and at the same time paying attention to the meeting itself. So thank you, Ram. When I actually put myself in the queue, it was not so much to speak about this, but was more to ask a question of what was your understanding with BBF on what they wanted from their network resource model, and if there was an overlap or no, not an overlap with whatever work is going on here.
Yep. So basically, I wouldn't say an overlap. I would say rather they are working on something similar. They are happy to build on top of what we are doing in IETF. They need to describe, so they are defining an SDN controller for access networks. And they would like to define two models. One that exports the topology of the network managed by the SDN controller. The second one that exports the inventory of the access network. So they decided to investigate on what is available there, and they found RFC 8345 and the IV core model. And so they wanted to better understand what these models do, okay, how to use them, how they can extend them, and also understand what decisions took us there. Something like, for example, why we decided to have two separate models for topology and inventory and stuff like that. So okay, this is the goal of the work. Please, Benoit.
Benoit Claes as the NMOP chair. So I was not able to join the side meeting yesterday, but do you believe that there is something in this liaison reply that must involve NMOP with the digital map?
One information that we shared with them is that NMOP is planning to update RFC 8345. We have some bureaucracy to solve because RFC 8345 belongs to a closed working group of a different area, but that's some IETF internal stuff. From a digital map point of view, I don't know, probably the digital map work would fall into the new scope of RFC 80, augmented RFC 8345. What do you think?
I'm not sure yet. I still have to read the liaison, but whenever you mention one being inventory and one being topology, the topology one, there is maybe something with an up to be checked.
Yes, absolutely. You don't have a working group document yet, because in our reply, maybe we can say to have a look at an nmop, but we don't have any document to link, right? Yeah, that I mean, that's a good input. We already sent them a verbal link to nmop, but we will make sure to make it firm. Okay, time to go to the core model. We don't
Hello?
remember the presenter. Chowde. Okay.
Hello?
So we have mod presentation. We can hear you.
We can hear you. Please go
Okay,
ahead.
thank you. Okay, hi everyone. This is Chowde. I'm glad to do the presentation on behalf of all the co-authors and contributors. Next slide, please. After last IETF meeting, we have done this update to this draft, and for the content of this document, the discussion of efficiency is not so related with the modeling or inventory. So we decided to move it to the appendix. And for the terminology description of container, it is very easy to confuse with the terminology of young container. So we provide some more description to indicate that the container in the content of this document is the hardware component that is being able to contain one or several removable physical entities. And we have also done some update on the data model, which could be seen on the pull request on GitHub. This update, including we adding a new root prior to the never element node. The new root, the reason why we need add this new root is to support the modeling of fiber and cable inventory. And we also changed the configuration capability of attributes after a long discussion. To be noticed that this discussion is still open. What we have agreed included we should start from a read-only data model at first, and for some user-defined information, it could be configurable from our interface. And people also suggested some more investigation is needed for more use cases. We have also done a lot of discussion of part number since never element is working as an assembly of components. There should not be a part number for never element, so we remove the part number attribute from never element. And we also changed the description of components part number attributes. And in last IETF meeting, Robert suggest to move back the component specific structure, which is also agreed by many people. We have done several discussion, and finally we reintroduced the structure to the data model. But there is a little bit differences with with our previous secant work, and this will be introduced in the next slide. There is also some discussion, but no finalized conclusion have been reached, including the discussion of terminology and inventory. this discussion will be introduced by Nigel and Italo by the next 2 sessions. And we also discussed the modeling of fiber and cable, and also discussed the software patch. This discussion will be continued after this IETF meeting. Next slide, please. This is the discussion of how to reintroduce component-specific attribute structure. There were 3 options raised in the discussion, and for the first option, which is the CCAM approach, some people consider that this choice case provides some duplicated information with the class attributes, according to the discussion net mode. And for option 3, we remove the class attributes, but we also found that if the class attribute have been is removed, the filtering capability will be missing if the client want to retrieve a specific kind of component. So finally, we choose option 2. Next slide, please.
Sorry, can I ask a question?
Yep.
So, go back to the previous slide. Yes, so just a quick question. As a contributor, I'm wondering whether the authors has identified any component-specific parameters so far, or you just define the container there and leave there and open the door?
Currently, there's not too much discussion on this point, and we used to have some discussion in during the CCAM work, but no finalized conclusion have been reached. And we also prefer to do some discussion after this meeting to define some component-specific attribute in the core models.
Okay, thanks for the clarification.
Okay. And for the discussion of configuration capability or inventory, we raised some possible use cases which have been listed in this slide. People agree that we should start with the read-only model, and it is acceptable to define the user defined information to be read and write. And there is also a need to support configuration of intended or actual inventory object. This requirement is also raised by the BBF expert according to yesterday's BBF liaison side meeting. And for the other use cases, we agree that we still need some more investigation. Next slide, please. And for the discussion of fiber and cable, we have agreed that a new root container is needed for inventory prior to network element node. And for microwave connectivity, it should not be modeled in the inventory data model, but topology model. And because the fiber, sorry, and because the fiber and cable are passive device, and usually it is not managed by the management and control system, so it should be optional when implementing our data model. The scope of the fiber and cable is not limited to the inter network element, but also in the same network element. What have not been agreed for this modeling includes whether we need to align with the modeling of TAPI model, and whether we define to this part of information in the augmentation model or in the core model. Next slide, please. There were also some other discussions, such as the modeling of software patch. We agreed to add the software patch revision list for the component objects. And for the part number discussion, I have mentioned in the previous slide. Okay, next slide, please. And for the next step, we would like to continue the discussion of terminology and use cases. And we will continue to discuss the modeling and fiber and cable. And if we have got enough input, we will start the discussion of MPO modeling. And we will also try to close as many issues as possible on the GitHub. Okay, that's all for my presentation. Today. Thank you.
Mahesh, so I had one question and one comment. You define network inventory as collection of data for network devices managed by a specific management system. What happens if there is a service level management system that is overlooking multiple domain management systems? Wouldn't there be a need for a network-wide instead of a management-wide inventory model?
Sorry, what do you mean network-wide inventory? I think the current data model is a network-wide inventory data model.
Okay, so there is some text in probably in the draft that might need some clarification. It talks
Okay,
about a single management system-wide inventory.
Well, actually, if I can add my 2 cents here, I mean, it's not uncommon to have a network which is managed by different SDN controller management system, pieces of software. So in that case, if let's make an example. There is one SDN controller which manages half of the network, and then the second one which manages the second half. Each SDN controller can only see the portion of the network that is under its control. So we would have two inventory models exported by the two controllers. The overarching orchestrator would have to join the two pieces together.
Okay, so there is that concept of that overarching management system that is looking at the entire network, not just the individual.
Okay. Okay.
Right. Okay.
So, I mean, yeah, what we can clarify in the text is the fact that let me use this terminology. The domain controllers export the inventory that they can see, and then I mean there must be the possibility to stitch the pieces together to have the full network view at the higher layers. That's something. Yeah, that's a good clarification.
The other comment is that the prefix used in the model NI is actually used by RFC 8529, the network instance model. So you might have to pick another prefix.
Okay. Okay.
And
Thank you.
NIV could be one.
NIV. Okay, good.
Thanks. Next one, Kent.
Kent Watson. When I did an inventory model many moons ago, a couple decades, I think now, a big consideration to that model was the impact of installing line cards or licenses, and specifically with an increased capability, like number of VPNs that could be supported. And so my question is, are you thinking about this at all? Like how inventory impacts capabilities? And also, are you thinking about software licenses as being an inventory artifact that's being managed?
So maybe I can start and Chaude can chime in. I wouldn't say that an inventory should tell you you can build 10,000 VPNs or 15,000 VPNs, should it?
Sorry, what's your question?
I don't think that an inventory model should be able to tell you in this network you can build 10,000 VPNs rather than 20,000.
It's related though. If it's not, directly part of this working group activity, then it's going to be an adjunct activity to this working group.
I mean, we can consider it as an augmentation for sure. I would keep it out from the core model and would have maybe a dedicated extension, a dedicated augmentation. I would say it falls into our charter. I would just keep it out from the core model, also because we are trying to shrink it to deliver it as soon as possible, and then it can be extended in many ways. Chowder, you wanted to add something?
Okay. In my understanding, the inventory, the previous inventory has a very broad or concept. Everything could be called as inventory in the previous control and management system. And for the core model, we need to make it more simple. So probably just like what Daniele said, uh, the capability could be the could in the scope of inventory, but probably it is not in the scope of base model. Also, I think for the capability, there will be a lot of argument about the boundary about inventory and topology. So probably the capability could be defined in the topology data model instead of the core inventory data model. Okay, sense?
No, on that, and when, on that one, I don't agree with you. I don't think it's topology. Probably it would be a dedicated, separate augmentation, but I wouldn't call it topology. The fact that you have given capabilities or not.
Okay.
Please.
Well, yeah, okay, Italo, I have two comments. So first, on the previous one from Manesh, I think we can clarify that this model can be used on hierarchical architecture, so that each domain receives this domain, and then you can go up to how much you can. Yes. On this, I think at this moment in time we are using topology to provide the capability. So I think, and we can navigate from the inventory to the topology to see. So you can say how much VPNs a node, an existing node can support, because when you start provisioning services and tunnels, you need to have this capability information. What I think is hard to do now is to say, I need more VPNs, so what type of board I need to insert, which is a little bit more complex.
Exactly. What you get in the topology is how many are there.
How many you can use, yes. Not how many you can use if you add this board or if you add this other board. That's more complex.
No, but I think it's a very good input. It's something that we have not considered so far. It's something to be considered for the next steps. Kireti, please.
Hi, Kiriti. To follow up on what Kent was saying, I think it's interesting to have capabilities of devices. So how many routes I can carry, maybe how many VPNs I can carry, but definitely how many routes I can carry. On this port, I can do VLANs, but how many VLANs can I do? Maybe I can do the full 4,000, but maybe I can only do a few hundred. So those are interesting things. I think we should make them as initially as private augmentations, but it would be good to settle a list that we want to add, maybe as part of the standard, and then there'll be always more capabilities that you can add later.
We'll wait for a draft from you.
Okay.
This is Bo from Huawei, and about like the previous comments on the how to the topology can be have some relationship with the inventory. We also have a draft working on this, so we like to collect the feedback from all the members to see whether there are some also have some thoughts on our draft improvements. And because we also have some software extension and also has the location extension. Also, there's one has an entitlement extension, but I think we like to collect the comments from the all. Thanks.
Diego.
Yeah, Diego Lopez Telefonica. That's what Kiride was saying is a message from our sponsor, in the sense that that we already have been working on a draft that is about the life cycle management, in which we are talking about, we don't call it capabilities, we call it features, but this is something that if you're interested, we can have it's ongoing.
Mahesh, I had actually a clarification for Kiriti when he has a minute. Kiriti, okay, sorry, this question is more for you. So, when we talk about inventory and specifications like number of routes, is that something that can be actually specified upfront? Because it's a capability of the system that can change also based on configuration.
I want to use inventory to be able to do placement of services. And so I want to know, is this box capable of doing a layer 3 VPN? If it can, how many can it do? How many routes can it support? And typically that's not, a number, but it might be a range. It depends on various things that are happening. So there's a upper bound, and then there's a current capability or current level. So these are what I want from an inventory system. We're building our own, as Kent was saying. There he is. So if we can use a standard model, we'll be happier. But I have to do some reading, so I'll come back. But and especially that was just mentioned. But
Rob Wilson, Cisco. I think we're into the weeds slightly here because we've got to just remember that what we're focusing on this discussion here is the base inventory model. And this is what everything else is building on. So all these are valid conversations, but actually they don't really focus on what we need to solve now, which is trying to keep the base model simple, and then we have everything augmented in. And once we start adding those augmentations, have those discussions and try and figure out how they fit in. But let's keep the base one simple and get it done as fast as we can.
Yeah.
Yeah.
Okay, Kent again. Just want to double down with what I was saying before. I also called it capabilities, not features. It'd be a config false node, and by port, by line card, etc. And it was modeled also how each license would impact that capability. Like this license does a plus 50, this license does a plus 100, or this line card does a plus 10,000. So it actually was built in that the inventory model would directly lead to an understanding of the capabilities of the box and the max configurations that could be done to it.
Okay.
I also disagree with Rob about trying to do the minimum possible to get it out faster, because I think it's short-sighted and you'll likely come out with something that's not going to meet the actual expectations of operators.
Well, I have to say that here I agree with Rob, because I mean, building an augmentation on top of that in step 2. I mean, it doesn't say we are not meeting a customer's expectations. So someone that stops at step 1 can have pass me the term, basic inventory capabilities without the features capability and so on and so forth. We are not saying that is not something that we won't do. We are just saying first, let's deliver something which is a pure, simple inventory first, and then add on top of that. That doesn't mean we are not working on that.
Okay, yeah, I understand the desire, but just look at the topology model, right? They did something very simple, and now there's like 60 augmentations and spaghetti, so we have to bring up a whole new working group to clean up the mess, right? That's what's going to happen here.
Hopefully not.
So it seems we're just closing this working group, yet a new one.
But
I'm going to reinforce what you want to say.
But we did the mess to give Benoit some work to do.
No, actually, I understand all the comments. We need to have inventory. We need to have capabilities. I want to have performance metrics. I want to have energy. I want to have all this. The key message is that if we just augment the couple of key concepts from RFCT 345, and we're doing this here, it's a pointer between those concepts to performance metrics, to energy management, to capabilities. And this is exactly what should happen. I don't believe we should redefine the scope of this working group. If you focus on inventory, you do it right, it's a great job. If someone else does the performance metrics attachment as pointer, do a great job. If someone else wants to do capabilities, and we would need that, it's a great job. this is pointer to different databases. Rob agrees.
Yeah, Tim,
We have
actually,
Italo before, but if it's okay,
yeah, I just want to, support, Corrady and Ken's proposal about this inventory capability concept. Besides the VPN use cases for energy management, actually, they also need this kind of capability to describe whether you support energy saving or what method you used. And you may set a boundary for some power monitoring, voltage and current, right? So this is a very useful concept.
I would like to comment on the mess. I think the problem is you never have when the problem statement is too big, you never have a right solution. If you put everything in one model, you create a monolithic monster, and you can look at 8795 about an example of a monolithic monster nobody likes. If you split into multiple modules, and people say, "Oh, there are too many models. I don't know how to combine all of them."
at least you can pick and choose.
The good advantage exactly is that you can pick and choose if you have small pieces in that. What we are doing, for example, in SICAM, we are starting to do some applicability statements where we provide some guidelines for specific use cases on how you can combine all the different pieces. So you have a modular design, and then you can have some guidelines that help. Okay, in this particular case, you can combine these modules and have something that works in a consistent way. On the other side, even if you want to go to the monolithic monster, we can also go step by step. We can also do V2, V3, V4 of the same YAM model. So doesn't preclude having a version 1 small, a version 2 bigger, a version 3 even bigger, and then in version 10 you have a monolithic monster. So we have plenty of tools to go step by step.
I'm more in favor of building on top pointers, etc., rather than ending up with the monster.
And last comment to it, I think that the number of VPNs that you can support, in my opinion, that you can support now should be in the topology, not in the inventory. And then we have a reference between topology and inventory if you want to know.
Okay. Why not having as a third item? Why does it have to be inventory or topology?
The problem is when you have both, you have duplicated information, because sometimes you may have only topology, sometimes you may have only inventory. When you have both, then you have.
If you have only inventory,
you don't care.
Speaking about the core model, you don't care about how many VPNs you can do.
Yes, correct.
If you have just a topology, you don't care about how many VPNs
you care
can build.
Because you want to create services.
If you have the third model, it's because you care, right?
Well, with topology, what do you do with topology? You want to know how many services you can set up over it.
Sorry? Could understood the capability mentioned by all the people who raised comments. I think there will be two different capability. One is a stated capability, which is the total number of VPN could be supported by the inventory. The other one is what could be defined in the topology model. That is how many VPN service or capability could be supported by the current inventory resource. Not it is a little bit different. Sense. And if for the stated one, I think it should be defined by the license inventory, not by the not by the base model. Okay, sounds.
Okay. So thanks, Shufang, for timekeeping and closing the queue.
Yeah, please keep your comments brief, Aihua. Keep your comments brief. Yes.
Yeah. Okay. So just to add to it, to Chao's comments, I think in general, right, if you have topology and inventory are two different levels of abstraction. Topology could be more abstracted. So what is represented in the topology, the capabilities could be different from what you actually have in a device. So I tend to say like it's also different, right? We may consider adding capabilities to the inventory models, but that's different from what we talk about in a topology.
Guys, I hope you had a very good coffee because this presentation is tough.
Thank you. So yeah, I'm going to talk on Ivy boundary. I've got some fairly detailed slides in here. So this is the tough bit. And I will talk on capability a little bit and various other things. So the purpose of this presentation and the work we're doing associated with it, there was on the first slide, there was an actual issue that was raised that we are following up on here, is to define the boundary on the work we're doing and to define it in such a way that we can understand the relationships between this work and other work and so on. So I'm going to set some scoping definitions to try to help us understand the problem. And then I've got a pictorial boundary, which I'll go through, which hopefully again will help. Then I've got some pictorial boundaries a bit lower down that get very, thank you very much, very complicated, which I'll probably just touch on. You can look at later. And hopefully, as a result of this, we'll actually have a clearer understanding. Iflo's going to go on after this with work we've done this week, tightening the boundary up further. But I will provide some examples of things that are in and outside the boundary by this definition anyway. So, busy slide. It seemed worth breaking the problem space of things down into a number of broad categories. So, why is positive things written in the middle of that slide?
Not very positive.
What's it doing there? Anyway, right. So, ignoring the error on the slide, the things you can break down to physical things. That this is what we're focusing on in the inventory work. Physical things, you can measure them with a ruler. Sometimes weigh them with scales. That's physical. It's a thing of real substance. A functional thing is you can't measure it with a ruler. It's something that does something. It's behavior. It's a separate sort of thing, and you can, well, as I'll show it later on, the stuff in RC 8245 relates to functional things. The stuff we're looking at physical, we're not looking at functional things and inventories of those. Informational thing, which is a collection of data, can't measure it with a ruler. It doesn't do anything, so it clearly hasn't got behavior. And then motivational, with the word positive things written on it in the wrong place. Motivational things, this is something that drives the behavior essentially, so it's power. So if I get a physical thing, I augment it with information, I then power it, out pops functionality. So that's the way those things relate. And it seemed important and helpful to actually divide the problem space up into that in that way to help us identify some boundary. And then positive things, which is supposed to be heading on that lower bit, assets. So something I own that does something useful for me, and I may have some kind of asset identifier, and a resource, which is a component or commodity that is useful that doesn't necessarily have that identifier. I might not own it yet. So resources are things I might not, assets are things I do own. So examples of things on the second column: a circuit pack, a physical thing that's a resource, potentially an asset. It may not have an asset number on it because it may be some tiny little passive thing. I don't bother putting asset numbers. I have in a bag and I just sort of distribute them. Termination point, functional thing, resource, not necessarily a formal asset because I don't stick an asset ID on it. It's more ephemeral and so on, may appear, disappear, maybe emergent. A Yang model, this is informational, it's text. It's clearly a resource, it's not an asset in the same way again. It's gives rise to functionality when installed on a powered piece of hardware. So likewise, software image, very similar. It may have a formal asset number on the software type, so you may choose to make that an asset, or maybe a smaller component of some asset. And common separated data, that's informational. It clearly doesn't change the behavior when you set, so I've got some performance there, it doesn't change the behavior. So trying to sort of categorize those things. The term motivational isn't necessarily a very good term. So if you've got a better one, please. But hopefully the other three terms make sense: physical, functional, informational, and motivational. So then looking at the word inventory. So the problem with the word inventory is in English, it just means list of stuff. So we talked about a list of any old stuff. So you can have an inventory of anything. You want to have an inventory of spoons, etc., in a drawer. Sometimes with location, so I might define the place. It's the spoons in my drawer. But it doesn't tend to give a structure. It's normally just a list of a pile of stuff. Whereas in Ivy, we're looking at structure of physical things. So although we put the word inventory on, it's slightly different to the general term. So we need to be very careful to define what we mean by inventory. It's not just a list of stuff. It's a list of, it's a structure of stuff. we're looking at physical things and some physical things, which I'll highlight in a minute, and some informational things. There's a boundary. We're clearly not doing inventories of spoons. So spoons, physical thing. So we've got plenty of functional models in IETF and RFC 8345. So we're not looking at defining models for functional things, clearly. And we're not looking at inventorying functional things either. So listing those or doing the structure for them, because that's done elsewhere. Now, if I try and draw, this is a pictorial thing. You can look at it in more detail afterwards. The key is obviously too small to read, but I'll try and help. There's no laser on this thing. There isn't. I can't actually get the microphone and the laser up onto the thing, so I won't do that. So there's in that picture, there's a blue ellipse that represents the traditional term network element. Within that, I've got some physical things, which are the circuit packs, and I've got some informational things, the software. And I've got this power, which is sort of motive force that drives that solution. And the physical things in the network element are in IV scope. The informational things in the network element, some of them may be in IV scope, some may not be, and we need to look at what that means. The motivational bit, the power, not within IV scope, we're not looking at that. So that's sort of like the initial focus on the thing. So it's physical things, circuit packs in network devices. And taking that further, I now can put on here the blue stuff, that's emergent behavior. So that would be RFC 8345's scope, not the IV scope, but clearly a relationship between that and the physical thing. So physical thing gives rise to the emergent behavior when powered. Likewise, the management control off to the left-hand side, that's an emergent thing from the physical environment when powered. And again, we're not doing an inventory of management control items that might be running on the hardware. So hardware, physical things, some informational things, not functional things, so not the termination points and not the management control stuff. The diagram gets more complicated in a moment. But then looking down the bottom at the brown bits, these are physical in this diagram. You've got fibers, ducts, things of that sort, not in the IV scope. Manhole covers, not in the IV scope. Still physical things, but not in the scope. They don't tend to be serial numbered and inventoried and so on. So we're looking for that to sort of help us define the boundary. Understanding the geography is important, so knowing where the thing is, but not modeling the geography. Understanding locations that are not geographical, again, building locations, but not modeling the buildings. So we've got information that's associated with the imagery items we are covering that is critical, but we're not modeling that in detail. So going on to the next slide, rather than pushing the laser. So here's the bottom of that diagram expanded a bit just to pick some further physical things there. So the upper part of that is the boards in the network element again. And then we've got down there a spares cabinet, and there's some boards in the spares cabinet. Are we doing those? Well, we had a question about that. I thought I was going to talk about the resolution to that question, but when I put these slides together, it wasn't clear whether we were modeling and expecting to provide an inventory of spares that are not powered in a spares cabinet so we can track their life cycle around the thing. Then on the right-hand side there, I've got a circuit pack in a truck in a box. We're not modeling that. So in the process of it being delivered, I may have purchased it, I may have an asset number for it, but it hasn't come from the factory yet. It's just being delivered now. And on that basis, it's not within our scope, we said. And then we've got capability information, which we talked about just now. Clearly, capability is related to the hardware and can potentially be modulated by policy and other things to restrict what I want to do with a particular thing. So there's a complicated space in that area that we're not modeling. We put capability down with a question mark on, but again, I think we're going to resolve that. And whether we inventory or not is a very complicated model in that area we'd have to think about carefully. We did some work in O&F on that may be useful at some point to look at, but so not the spares cabinet probably, but it'll talk on that, and certainly not the board in a box in a truck, although it's still the same piece of hardware. And then an even more complicated diagram that I'm not going to go through in detail. This one's just showing that, yeah, that space at the very top is the same one I drew before, but I might have a virtualization environment under that where I've got some hardware, that's the middle ellipse, hardware running in a data center that's I'm running virtual devices on and virtual functions on and so on. that hardware may not be in this inventory, and maybe it may not be. We need to think about that. Same sort of hardware, it's compute board, it may be the same sort of board that was in the real NE, but now it's in a completely different space managed by a different manager and so on, and just using the emergent behavior, so maybe not. And at the very bottom, there's the hardware that runs the PNC itself. Is that in scope or not? So we're trying to say, well, are we going to, because otherwise we're doing all compute hardware and so on, and potentially we wander all over the place again. So the danger is this space has got lots of slippery slopes that we can slide down and end up trying to model everything. So we're trying to say, no, we're keeping it tight, and we're keeping it on telecoms hardware, and telecoms hardware that is about to run or is running, not telecoms hardware in a truck, not telecoms hardware in a spares cabinet, is where I think ITLO is going to take us. So here's a list of stuff. I'm not going to go through the whole list. Here's a list of stuff that's in and a list of stuff that's out. So as I said, the telecoms hardware in, you can read the list afterwards, but and ITLO will do a bit more on this. But things like cables, ducts, things we can't talk to, buildings, trucks, stuff like that, absolutely not in the inventory, although it's physical. So that's the essential boundary definition. And what we said we'll do is we'll actually define, so Daniela made it very clear that we need a definitive list of what's in, which we will therefore generate. We clearly don't need a definitive list of what's out, because that's an infinite number of other things. But so we can draw some examples to help emphasize the boundary. So it's vital that we have clear scope, because there are slippery slopes all over the place for us to be able to develop models that we've already got elsewhere, or models that have nothing to do with our space and so on. The coarse categorization of physical, functional, informational helps divide the problem up. Some aspects are still uncertain, which we're exploring. ITLO will clarify further on this. And at the moment, the examples are not exhaustive, but as I said, we will put an exhaustive list of what's included and examples of what isn't, to help just draw that boundary further. So the next steps of continuing to refine that boundary and agree the boundary within the team. So that's where we're at. I think that's questions.
So you understand why it was difficult to create a definition that clearly says what is in and what is out. Our proposal was to have in the draft a definition good enough, followed by an explicit list of what is in and what is out, like the one that you've seen. So I would like to ask you to send a proposal of the list on the mailing list.
Yes. Okay.
So that everyone can say, I would like to add this, remove that,
Yes,
and
yes,
so on and so forth.
Yes, and we can use the slide pack, as a reason for not putting it in or putting it in, hopefully it will give us enough boundaries. Go ahead, sorry.
Yeah.
Okay, Huawei. Actually, two question clarification. If you come back to 2 pages before, with
Okay,
the proposal
2 pages.
in and out of scope.
Okay.
Yeah, this one. So I'm trying to understand what does it mean by out of scope of IV? Does it mean that based on we would recommend not to do the augmentation on the IV models for the right hand?
For the things on the right hand column,
Okay.
it's to not do those things, so we won't be doing an inventory of fibers and cables and manhole covers and buildings where we actually model the building as an explicit thing. So that was the intention. Yeah, we're not doing the models for those things explicitly.
Okay, and second question is regarding the boundary of base model. The proposal in scope, I think we will also manage it step by step. And the first step we will achieve is to create the base model. Do we have a line, for example, somewhere in the middle where the base model should cover?
So we were looking, one place we were drawing a line before was, we might do physical things first and then informational things second. So the lower part where it says software, we might defer that from the initial thing. We may not do, but so we don't have a line yet. And we may say all of those things need to be in the initial models. They all need to be covered properly. So we don't have a proper line yet.
Okay, so this is a perfect discussion for the mailing list.
Yes,
Put the
right.
list there.
That's right.
Draw the
That's
red
right.
line, etc.
Rob Wilton, Cisco. So I think it's great you're tackling what appears to be quite a tricky problem to try and define what these boundaries are and things like that. I think it's good that this model, so I'm more interested about what's in scope than what's explicitly out of scope.
Yeah.
And in terms of what goes in the document, I'd rather it says these are things we intend to cover.
That's what we intend to do. Exactly.
And say
right.
nothing about the things that are explicitly out of scope. I'd leave those just as unsaid.
Yes,
Okay,
but we needed to track somewhere because you might say, okay, but have you considered this? Yes,
Yes.
and it's in the no
Right.
list.
So
That's
we can keep that out. I mean, maybe it's a separate
It can
reference
be,
thing. Yeah.
I mean,
But the important
whatever. It can
the
be
important thing is to
GitHub, but-
record. The important thing is to record it and record the reason. So when or the you
Not
put it
to
into
forget
a general bug. Otherwise, we'll just have it going round and round and round and round again. So that's
and
a problem.
And agree. And I would actually, I mean, having a draft that the working group's keeping and things progressing, even if it doesn't go to RFC, I think that's a useful thing for that. That discussion.
A
They got
draft
record.
for remember that we don't want to do this.
A draft of what we're not doing.
Effectively, that we've got
Yeah.
consensus on these things are in and out of scope. Ultimately, some of this may end up in the charter. So my when I chartered Ivy, my vision was the focus is on this base model, and that's the goals of the charter and what it defines. And then the working group, once it's delivered that, it would re-charter. And at that point, it's then saying these things in and out of scope.
Yeah,
So then the last comment I wanted to make is I think it's always good with these models if there's a level of flexibility with them, so that different people who are using the models have that flexibility they may say, actually, well, we want to include these things in and have that ability to do that.
Right. That's right. I think we were talking through that recently as well, and I think it's important that we're not restricting the use. So if we define a piece of say a model for a piece of hardware and it's got serial number, it's got type and so on, and then somebody wants to use it for a representation of the things in a spares cabinet, that's fine. We should have the right detail. But what we're saying is we're not doing the use cases that would cater for that. We're not doing the life cycle that would cater for that. So the model should be broader than the usage that we apply in the document.
And that sounds fine and good to me. And things like if you're using Yang identities, again, they give you the flexibility to define new identities and derive identities. That has that flexibility, the model can support that.
It's extensible. Yeah, exactly right. Exactly
sounds
right.
good. Thank you.
Thank you.
Yep.
Joe Clark, Cisco. Thanks, Nigel. Words are hard, and you've done a good job here, I think. But I am confused of one thing. If you go back to, I think, your second slide, you said it a few times, and keep going.
This one.
That one. You said physical, and you defined it as something that you can measure with a ruler, which, okay, that's very clear. But the base draft, the currently adopted draft, does talk about a virtual network element.
Yeah, so a network element is not a physical thing. And I've got a big history in this in TMF and ONF where we decided the term network element was actually a problem in itself because it isn't really a thing. It's a grouping of stuff. And if I was having that discussion this morning, actually, I'll try not to make this too long because that little clock will go red in a moment. But I think if we go back like 40, 50 years, network elements were single shells with a single management access and a single function. It was all nice and singular. Then you move through the history of these things. They become geographically dispersed. They have multiple management accesses. You can see one part through one through another, etc. And we decided that concept was essentially broken. And what you're really looking at is a grouping of stuff that you're interested in, which you can get at through a management interface, which isn't a physical thing then. So a virtual NE is just a grouping of stuff that has no hardware in it. It's only got functional things. And that was where I was sort of going with the network element. It isn't a physical thing. It's a management control concept for grouping stuff together I'm interested in. That it has a combination of functional, physical, etc. And it isn't any of those things. It's just a grouping. I don't know if that makes sense.
I'm a simple guy. I just
No, you're not.
I just wanted to understand what is in scope in your terminology and forget a distributed system. Let's say I install an OVA that is a virtual router that could support everything I read about, like entity type stuff.
We have got that it's a very thin shim so in that case the virtual network element is a very thin shim of stuff. No hardware, supports functions. The functions are not in the scope of Ivy.
Right.
The hardware isn't present. So I got a little shit. We have talked on that in this impossible to read picture.
Now you understand why we gave up and have the list.
In this impossible to read picture here,
I see virtualization down there. Yeah.
So it supports functions, but it doesn't have any physical realization that you're going to inventory because that's somewhere else. So that's the one that does the virtual NE. So the physical NE is the hardware that's impossible to point. The physical NE is the hardware that's there. The virtual NE is hardware is there below the virtualization layer, and therefore it's not relevant in the inventory because it's somebody else's stuff, essentially. You could inventory that, so that's why it's got Ivy question mark.
Okay.
But we said, well, we want to stay away from inventorying the data center's compute hardware because
Sure.
that's somebody else's problem.
Okay.
Is that sufficient?
A little, I'll wait for the list and I'll reply there because I'm taking way too much time. Thank you.
Thank you.
Mahesh, I think my sense of it is that based on all the discussion in the room, is the confusion around capabilities. Is it in scope? Is it in scope of Ivy? Is it going to happen somewhere else? I think that's maybe a discussion to be had is what is, are we defining capabilities and where are we defining it?
I mean, capability is critical. I fully agree with you, but it doesn't really fit in what we're trying to do with Ivy, but it is critical to do. So, Chris.
Hey, Nigel. Christian, Sienna. I know you defined it or classed it as
Did
out
you
of
say Sienna?
scope.
Did you say Chris?
I didn't say Sienna, did I?
You did.
Oh my God.
He's coming back to work with you.
Yeah. Take one look at you and a flashback. Yeah, sorry, Huawei.
It's a city in Tuscany.
Huawei. Christian's Huawei. I'll just introduce him because you've
Too
forgotten
many
who he
good
is.
conversations over beer somewhere in the past.
Right, go ahead.
So I know you put it out of scope for this work, but I'm intrigued trying to understand this motivational things
Yeah.
category. Usually when you come up with something, it's for a good reason.
Yes.
You've used the example of electrical power and you've described it as almost like a divine spark or
Yes, that's right.
breath
that's right.
of life. So I'm just
Yes.
wondering, what do you really intend in that category? I mean,
to put it out of scope. To put it out of scope was what I intended.
okay, well,
but-
no, I just
I get
wonder
you.
what it means. It's got to be, if it's just electrical power, it's not very meaningful. If it's a category of stuff that makes the difference between the operational status or non-operational status of something in inventory,
That's interesting.
then
That's
perhaps
interesting.
it's more.
We could talk on that separately. We could talk on that separately. It was there at the moment to say that there isn't just physical stuff, information, and function, because the function doesn't arrive until you do this thing. But then you're right, you could take that more broadly. Motivational was picked on purpose as a more general term, but I'm not sure if it goes anywhere. I'm not clear, but it's there and it needs to be accounted for, and we're not doing it in the inventory was the reason.
Yeah, I'm struggling a bit with what it means. If what you intended it to mean is whatever makes the difference between inanimate stuff and stuff that may be considered operational.
That's right.
Then that's interesting. Okay,
That's right.
thank
Okay.
you.
Okay.
Thank you.
Thank you.
Thanks, Nigel.
Hello.
Change deck.
Okay, this is a bit trying to a little bit summarize what we discussed on Monday. We had a side meeting on Monday. We tried to put down a few comments, a few ideas, and some initial list, and some open issues still to discuss. So what we started to define, to look at Monday, we said, okay, we can see a concept of asset. The idea is that the asset can be something which is owned by the operator, and the fact it's owned doesn't mean that it may be deployed or may not be deployed. And we can have, in this area, we can have informational thing like a software module image, which can, I own this software module, but I may not, I have installed it one or multiple times, or a license, and okay, the list has to be completed. We only mentioned these two examples. And the physical things can be a shelf, a board, or a physical port on the network element. And again, the list has to be completed. Then we said what can be a physical network element can be seen as an assembly of many things, because as Nigel was showing, we have informational thing. On network element, we have software running, we have a physical thing, board, and so on, and we have functional things. The network element can support layer 2, layer 3 VPN, OTN switching, WDM, and so far. And another important characteristic is that the way all of these are assembled into a single network element is typically vendor specific. So what you can see, this is a typical example in the optical network. You can see that I have a chassis with optical switch, OTN switching, a chassis with WDM switches. Some vendors show these two chassis sell it as a single network element with two chassis. Other vendors sell this as two network elements with single chassis. It's the same function, the same set of physical elements is a different way you assemble things. So basically, it's a vendor-specific assembly, which is putting all these things together. And another important characteristic we said, this is more applicable when we compare the physics with the informational, is that the asset can be deployed, a physical asset can be deployed, so it means that a given physical thing is actually deployed over a specific physical thing or another assembly. It can be, for example, a plug is owned, but is actually deployed, inserted into a given slot of a board, or a board is inserted in a given slot of a chassis. That represents what is installed where. Also, the physical asset is the software. Okay, I can have one image, but I can install this software over multiple elements. And the example that we mentioned to clarify this is, for example, let's assume we have 5 phones, 2 apps. We put some numbers, but I think and 1 SIM card. Okay, these are the assets that I own. I have 4 phones, I have 2 apps, only 2 apps, and 1 SIM card. I can deploy, the app number 1 can be deployed over 3 phones, and app number 2 can be deployed over other 3 phones, ABC and CDE. So this is describing how the informational element, which is the different apps, are deployed over different assets, which are the phones. Or you can have the SIM card, which is a physical asset, which is inserted over 1 phone. The difference between the informational element asset and the physical asset, the physical asset can only be inserted once, while the physical element can be installed, the informational asset can be installed many times. You have only 1 asset, many installations. Next is the opening.
Yeah,
sorry.
I moved it for you.
Okay, we got some discussion about, okay, we didn't complete, we have still some discussion. Okay, we didn't complete the discussion about what happens in this discussion with virtual NE. We have also still a lot of discussion about what is planned. So something which is not yet owned, but I want to buy, or something which is owned but not yet installed in a given network element. And we have also some comments. Unfortunately, this is not the latest version of the slide. But okay, I got there was some comment. The current model is actually describing reporting what is deployed. That is why it's needed to be read only as a physical or informational asset. So it's actually reporting on this network element. I have installed this board. I have installed this software SFP, and I have this version of the software running over the card. Another comment that we got is that there was some discussion in Ops area about license versus entitlement. So we need to clean up that terminology. And there was also in that the current model for entitlement is not considering entitlement as an asset. So there is still some mismatch between the models that we have and the definitions that we were working out, and we need to clean up. So I think we want to have some open discussion on this. So, yeah.
Kent, I'll get in the queue.
We assume you are the first in the queue.
Yeah, thank you. Okay, so I'm very happy to see this. This is more along the lines of what I was thinking. A couple questions. So one of the use cases I have in mind is being able to pre-provision devices, like in a network, especially to support zero-touch type environments, where the device hasn't been deployed yet, but I've modeled the network as if some devices exist. I've even configured services on that network. And so when the equipment shows up, I want those services to turn on automatically. So that's one. And then 2, part of being able to do that is the notion of connectors. So if you have inventory equipment, you might have a chassis which has like PIM slots, but the vendor, they might have different versions of PIM slots, like PIM version 1, PIM version 2, PIM version 3. So there's this whole notion of like, well, I have a line card, and the inventory says, it has a library of line cards, and for each library or line card in the library, it marks, well, what kind of PIM slot does it support, or can it plug into, so that when I'm trying to model my network, my equipment, I'm able to make those connections. So I'm just wondering if any of this is making sense, and is it connected to what you're trying to support?
Well, we are discussing that. For example, that's a part of the planning. So you say, I want to install this physical element or this network element that doesn't exist. I want to install it. I provision a service over this network element, and then when the network is actually deployed, automatic. You want to do that from the northbound of the controller, which is okay. That's important to understand. Okay, yeah. Okay, so that's an important use case we need to take into account. And I didn't understand the pin. So is about hardware compatibility.
It's about what?
Hardware compatibility.
Oh, yes, hardware compatibility.
Okay,
that's right. And so, yeah, I mean, I was unsure, and I apologize, I haven't read the draft, but
it's okay.
I was unsure if it's really just trying to capture what is the existing inventory.
At this moment in time, is mainly capturing what there is some ambiguity. That's why we are discussing it. Because different people have different opinions. Is about whether it's a purely read-only. There was also Chowder mentioned it. There is we have different cases. It can be purely read-only. I report whatever is installed, what I discover from the network. I give you. Or I can have something which is read-write. For example, there was some discussion about can I put a label over an existing asset, and then I want to configure this label. Or you can go to the extreme, which is what you say. I want to pre-plan and say I want to install this board in this lot, and I want to tell this to the MBI, and that's.
So this is again about drawing a red line.
Yes.
For sure, we heard about the requirement to cover also what is planned. Again, in order to deliver the core model as soon as possible to be used, probably this can go beyond the red line, but it doesn't mean that it's out. It means that it comes in step 2. That's it.
Yeah, I understand. And what I said before, I still believe is true about not agreeing with that approach. I really think that you should have a more holistic idea of what you're trying to do so that you know that things will come together correctly.
Well, there is an advantage, as far as I know, that if you change from read-only to read-write, it's backward compatible. So there is no big problem if you start read-only and you go read-write in the second phase. That's also something we need to take into account in the phasing.
Kireti is the next.
I'm also pushing in, sorry. So Nigel Davis, Huawei perhaps, Chris? Sienna, sorry.
Oh, two breaking news.
So just going back on the points there, yeah. So Italo mentioned planned. We have to be very careful with planned as well, because the point you're talking about is I already know exactly what I want to put in there. It's not the vague abstract planning. I think I might want to have that capability. It's specifically that bit of hardware, not necessarily the serial number, but that bit of hardware in that configuration with that software running on it, with that those expected emergent behaviors, those terminations are going to pop up. And then when it appears in the network, I discover it's there and I go, right, hardware's correct, bang the configuration in, put the software in, run it, and off you go. That's what yeah. So that thing sounds like it could be in scope because the hardware is the same hardware. But what we were saying probably is way out of scope is the abstract, I want 40 terabytes between those two cities and I need something there and there's a, that's way out. And there's a sort of a sliding scale all the way down from that to, I think it might be that bit of hardware, but I haven't committed it yet. And that's still probably out of scope. But once I commit it, then it's in. I think that fits with your zero touch provisioning case. So, and just on the capability, I probably said not to go
I think,
too much.
Nigel, maybe we better than planning. I think in the old days we call it expected. I'm expecting this. Expected.
Yeah, well, there's another the expectation in the device itself, because the device may be there and running, and you say, I put that expectation in that slot for that, but the device may not be there at all, and that's the one you're looking at as the zero touch. When I install it, I discover it and go, because that's the subtle difference. Because the device can't know what it's expected to be.
No, you can configure the device what you are expecting what is the expected configuration. I know in the old days for the optical SDH as well. You expect the board, and you can even start configuring the board before you plug it in.
That's right. But there's one final thing. Sorry, on the capabilities that's a critical area which is extremely complex. I think when you get into it, we did some work in ONF in the ONF core model, which is G7711. On that, we've got some maybe useful stuff we can bring into play, but it does get extremely complicated very quickly. So anyway, right, thank you.
So all you know that the world is Maya, it's an illusion, and we're all manifestations of this illusion, why are we so stuck on physical? I mean, seriously. Come on.
Okay. Yes. Let me answer to you. If nobody's laid down a physical fiber on the ground, there is nothing working.
So I'm not saying don't do physical. I'm saying let's treat virtual as a full-fledged member of this. So that's one. Two is about planning, and that's really important because things don't just show up in the network. They're planned. A bunch of things are important about it. You know, what software you're going to put, what connections you're going to make, even before it physically appears physically. So I think those two things should really be added to the charter. My meta question, since we're doing so much philosophy here, is which part of Daniele should I be talking to? You know, CCAMP or Ivy? And this is a question that Italo asked, or you mentioned that if you do capabilities, do we do it in CCAMP or do we do it here, or in topology?
At this moment in time, we are doing that in the topology model. So if you go, basically, the overall idea was that my box, this box can can be a layer 3 router, can be a layer 2 switch, can be an OTN cross connect, or can be a WDM ROADM, or can be a combination of the 4 functions, or any possible combinations I've seen of network elements we can combine these 4. So what you can do, you can have a pointer that we are doing between this NE and the different nodes in the topology. So my OTN capability is a node in the OTN topology. My layer 3 capability is a node in the IP topology. My layer 2 capability is a node in the Ethernet topology. So I know all my capabilities. And then when I go there, I look at the IP topology, I need to set up a service between P1 and P2. I don't care about which network elements it is. I do P1 to P2. So that's where I think I'm expecting to know RP1, P2 have enough VRFs, or I have enough VRF entries.
Yeah,
that's where I would like to look at, because then it's up. Then there is the second problem, which I think it's more complex, but maybe worthwhile to know. Okay, on P1 I don't have enough VRFs, but I want more VRFs. So now the question you may ask yourself is, which kind of board do I need to buy? That's a more complex word, but then you go down. But I think to understand what are the number of VRFs I need today, you don't need to know the network element specific configuration. You just need to know its functional view, which is already in the topology.
Right, right. So I agree with you. I think it's a question of, you know, which group to talk about these things in. And I don't particularly care. I just want that capability, that feature, whatever you want to call it.
Yes.
But I think that's something, because we're talking about what's in and out of scope of Ivy. But I think the question that I have is probably in scope somewhere. I just want to know.
Yeah, absolutely. Where. Yes. Well, then there is some implication about what, if you want to start saying what type of word I need to install to have more VPN. That's a little bit in between the two, so we need to discuss the details. Yeah, but yeah.
Usually, one approach that I like, it's let's do the work, and then let's see if it fits here or not. Okay. It's what we did with the CCAMP. We perfectly knew that inventory wouldn't fit in CCAMP, but instead of saying, hey, we would like to work on inventory, let's do the work, let's adopt it, and then we will find it out.
I like.
And we can always recharter one of the other group. Yes.
Let me first say.
I don't want any working group. That's it. I'm done.
No, but we know you love this one. No, well, let me start by disagreeing with Kiriti on the philosophical foundations of this, because I feel more Aristotelian than anything else. And reality is reality, but virtual things are real as well, and that's the point. I would say, no, and seriously, going back to this, I believe that we should start try to avoid the distinction between physical and virtual, because at the end we should treat the whole thing the same. A physical thing that you have in a box is as virtual as a software image that you have not installed. When you have installed the physical thing, you deploy the virtual thing, you have them. So we should I would advise that we forget about physical virtual, but we put a note somewhere that this can be physical or virtual.
If I can add, I completely agree with you. The thing is that if you say what is virtual in, you are opening the door to the entire world. So what is virtual? Yes, but what is probably a virtualized switching routing function? We need to be clear about that, because if we say if a virtual is in a firewall, is it something that you want to see there, or I don't know, whatever type of application fits in there. So we need to be careful to say what is virtual yes, what is virtual out.
Yeah, but in general, even that would happen even with the physical stuff, because you may decide that something that is measuring your energy consumption is part of the network or not.
Correct.
So, I mean, drawing the line is interesting, but I would
be
not
careful with that, because as my joke to Kiriti is also true. I mean, I remember at the beginning of VNF, somebody was asking, how do you virtualize a fiber? Sorry, you cannot virtualize, you cannot put a fiber in the cloud. You need to.
Well, that's
so
the argument we use from time to time.
So I will not stretch too much this physical. For people function, I fully agree. The fact that the function is implemented over a physical element or over a virtualized element, I can understand is the same function. Layer 2 switching is the same, layer 3 switching is the same, but some elements like fiber or some
sure. No, I mean,
really
I'm not saying that everything has to be considered virtual as well, but I would not make the distinction between this is a physical stuff, this is virtual stuff. At the end, it's a network element that we are going to activate, deploy, make available, etc. And two quick comments. One is about thinking about the RFC editor, looking at things and say, why are you using things so many times in the document? But that's something that probably.
I didn't catch your word. Sorry.
The word thing about we are using informational things. Whatever the thing, I know that is because it's a totally neutral stuff that because we want to avoid, but that would require some notes or clarifications. Just finally, we don't have a definition, or you have not mentioned what a functional thing is. That is something that we should have to refine. And to finish, something that concerns me a little bit from what I have heard before is that in some cases I feel that there is a intention of make a unique guidance for about how to use this, about the level of granularity, how the certain elements will be related to another. This is something that I believe we should avoid, because otherwise we are going the way 3GPP goes normally, that is telling you to tell all the detail what you have to do. And well, it's about offering possibilities, offering mechanisms for interoperability. As I know that right now it's difficult, but it's coming. It's something that came to my mind hearing some of the comments here, that we should be careful about possibility that if I don't care, or I don't care, or I cannot afford to be extremely careful about the specific models we have here or there, or I have a quite plain network in that sense, something that I should be able to avoid it.
Yeah, Huawei. Yeah, I'm trying to help a little bit by clarifying the responsibilities, because there is no right or wrong for splitting this physical information or functional things. So I'm trying to figure out, okay, who is the right people to use these models? Because when we start the inventory work, we start with the physical part. That is because in the operator, there are a separate maintenance team who need to, who is responsible for maintaining the physical devices. And the model we have here, the physical things, the group of nodes we are specifying here is just trying to help these people to identify where is the problem during a troubleshooting procedure. So we need to figure out which shelf and we need to replace a board, for example. And these are the guys who need to travel on site to work, and the model is just for them. But on the Meanwhile, I can imagine, for example, the informational things when we talk about the software and license management, there can be people sitting in the office and checking out how many users I do have and what are their status to do investment evaluation or whatever task. So, but I can hardly believe that two people I describe can be one single person. So if people agree on this, I would suggest we just separate the two modules by just maybe mapping or augmenting each other. But we can better modulize the work to make it suitable for different people.
Nigel?
Just wanted to go on about that physical thing again. So just once more, the PNF, VNF, and NFV, they shouldn't have been PNF and VNF really. They should have just been Fs, if you'll excuse my. And that's not what we mean by physical here. We mean genuinely measure with a ruler, weigh with scales, and hence, as Italo said, it's the fiber, it's the piece of plastic that's got the circuit, they've got the components on and so on. And therefore, there isn't a physical NE and a virtual NE. There's just the notion of an NE where I may or may not know the physical realization. That's the distinction here. So I'd say we need to be careful not to put the word physical in amongst the functional things. We need physical for purely physical, measure with a ruler stuff. And then the realization of the NE, I know the physical environment, I don't know it, is a separable consideration then. And the NE is then just a grouping of stuff which will be functional and may be physical or may not be in the grouping. So that was one thing. The other thing I think I've forgotten. So let me try harder. No, I've forgotten. Okay. So no.
Okay. Okay, so a quick time check. We have 34 minutes left, and we have 35 minutes allocated to the next presentations. We already used the 10-minute buffer at the end, but it was good to have the discussion now. So for the next presenters, please keep your presentation a bit shorter than the time you have to allow for questions and answers. Bo, you're next. Network inventory locations.
Hello, everyone. This is Bo.
If you want to click it.
Okay. And I will be here to present this network inventory location model on behalf of all my co-authors. As you can see that the similar authors drawing the base inventory model also join this collaboration work as well. So next slide, please.
It's a question for you.
You have the clicker.
You have the
Okay,
clicker.
okay. Here. So here is the inventory location model background. Inventory location model is trying to provide location information to the network inventory. It is quite critical information for the network inventory as it's provide location information to inventory so that in network planning, provisioning, and also the maintenance, it's quite critical. If there's no map of the place information, it's hard to replace it with some board in case of there's some problem with the board. So now you make thinking the location is quite critical, why it's not defined in the base network inventory model. Actually, the base network inventory is supposed to something that can be discovered from network devices and can be verified from the network devices. So usually this location information, actually they usually configured manually in SDN controllers or could be managed in the OSS systems. Then the other, this is why we think this location model is quite necessary. And the other consideration that we have been discussed during the base inventory model discussion is how this location model can be modeled. Previously, there are two kinds of approaches. One is a quite specific one that can be, there can be racks and rooms, that kind of approach. And the other approach is a quite general one that can be site with some geolocation with it. But so in this new inventory location model, we try to integrate both of these approaches in one model. So what do we have in our network inventory location model? There are major three parts. The first is location list. It is a general, it's a quite general list that can be a generalized site, a building, or a rack, or some room. This can all be generalized in this location list. And this location list can also have some physical address and geolocation information with it. So then the location can be have complete information. And then another aspect of this location list is that this location list is not a flat list. This list can have a hierarchical structure in it, such as a site can contain several buildings, and a building can have some room, and room can have some racks in it. Next, we have a rack list. This is a quite core model that if the devices install this rack-based scenarios. In this rack list model, we try to provide size, what size is the rack, and also the power capacity of it, and also the accurate spot that this rack can put into the equipment room. And lastly, the last part is that we also extend the base inventory model with the location. It could have some location list, and also it can be reference to a rack. Now, we have discussed this location model quite a while, but the discussion is still ongoing that even this model is trying to build a flexible, like the location list can can apply to some scenario that this devices doesn't need rack place management, or the building rooms can be extended in the future if some scenarios need that. But we also have some different opinion on this model, that someone proposed that racks can be put under the location list. So we like to collect the feedback from the working group. So in summary, right now we think this model is quite important, and we like to solicit our working group feedback for this model. And after this base model has been stable, then I think working group can consider adopt this work as well. So
for sure, this is part of our charter. So
yes.
it's
Any questions?
Do we have any comments?
Diego.
Is in the I think that this is obviously valuable, and that's not. But probably I don't know how to deal with it. But talking about the virtual stuff and all the like.
Where is located the virtual?
No, no, but this is something that is important as well. There are cases in which if there's something that is not deployed, you have the thing or the information. Let's not say about something that is virtual. Let's talk about informational stuff. Okay, so an informational stuff is something that can be somewhere in a repository, in a database, etc. Would be important to deal with this kind of locations as well, because it's information very valuable. Simply that. So either just for Bo and her colleagues to consider it, or for leave the door open for a future augmentation to deal with these informational matters.
Well, let me use this opportunity to get some requirements as inputs. What type of location information you would foresee for virtual stuff? Like the device it's deployed
Typically,
in, or
typically a URL,
Okay.
a URI. I mean, a way of accessing it, so I know it's there, so I can go there to get there. Probably a URI would be more general, I guess.
Okay.
Thanks for this.
Mahesh?
Mahesh, the question on what's the understanding with CCAMP working group on this location information? Are we moving it out of that draft into the draft here?
So the original plan was to do every non-technology specific work done here and the technology specific work done there. The more we work on it, the more we realize that this distinction is very hard to do. So probably we can consider moving that work here.
Okay.
Okay.
Kent?
Yep. Hi, Kent. I've also done locations. Well, one thing that came out of that effort was operators have different ways of describing locations. Some operators, they're metro oriented and they talk about city, building, floor. Others are, national and they talk about states and things like that. You mentioned you had an actual net yang type, I think it was called rack.
Yeah.
But sometimes they're called cabinets. And so actually hard coding these values or labels, I would be cautious of. The way I did it was to allow the operator to specify their own hierarchy of location types, what made sense to them. And, for instance, silly codes, so they could create their own silly codes. And so anyway, that's my only comment, is just be cautious of hard coding specific labels.
Okay.
So something like defining, for example, I don't know, 5 levels of hierarchy and then strings to define what those levels are, something like that.
Yeah, kind of, yeah. So like, for instance, I mean, some buildings like data centers, they talk about rooms or suites, or they have cages. And, so there's actually distinctions amongst those. And so allowing the operator to use the terminology that's familiar to them is what was a key takeaway from my effort.
Good input. Yeah.
Okay. Thanks for your input.
Thank you.
Thank you, Bo.
Next presenter is Diego.
Oh, we have not yet heard his voice, finally.
Sorry. I was just waiting for the next speaker.
It's you.
Thank you. So this is about the a draft that is right now 00, but the 00 here. So this dealing with asset lifecycle management. And in the old days, we were part of, or this was part of some effort that we started in OPSOC. I guess that this is something that is very common in this group, that we are trying to consolidate things that were happening elsewhere. And after deciding, well, after participating, sorry, the air conditioning and the weather is killing me. After participating in the chartering of Ivy and deciding to move to Ivy, we made some restructuring that was introduced in Prague, in which we separate one talking about in general the problem statements and what we wanted to do, and which is the general information model in which we wanted to base the actual data model that would be in another document. Since then, since we were talking in Prague about this, we have done nothing. And that has been totally intentional, because we didn't want to diverge more from the models that we're discussing, that were being discussed as the base model, in the terminology, etc. What we have done, And those of you who have been participating in calls and yesterday during the site meetings, etc., you will have heard myself, have heard Marisol, Camilo, and Frank, is that we have been trying to align everything so that we can make grow this proposal on a ground that is common and is commonly understood. So our intention is to find the consensus on the elements that we are dealing with, which are asset, feature, and entitlement. If you prefer capability, I'm happy. I mean, not that I'm going to be that on that, though maybe there are some distinctions taking into account what CCAM is doing and what we intend. But anyway, that's something. And basically with the issue that it was the one important for us is issue 38. In GitHub, that deals with the definition of asset, entitlement, and feature. If I remember well, it was Italo, if were you not, pardon me, but it was Italo that reminded us the TM forum definitions for the three stuff, from the three matters. Yeah, let's start using stuff and thing. And well, we are, our intention is try to follow as much as possible this. I mean, the asset is something that is valuable and is owned by a particular organization. And entitlement is something that allows you to perform some actions on the asset. This is important because we believe it's important that we distinguish this from license, because a license implies some commercial, legal obligations, and an entitlement is something more general. And then we have a feature that is a specific functionality or capability, and this is where we can, that is associated with an asset and is enabled, among other things, by an entitlement. So we won't, as I said, the idea is that we are going to refrain to make big updates of the documents, and in the meantime, try to contribute to the base documents and try to contribute to the terminology with this in mind. And this diagram is from one of my colleagues. It's try to identify what we're intended to do. I mean, the inventory, the base inventory is basically a listing and a connection of what you have. What we are trying to do is, based on that, and as a part of the potential applications of that inventory, is to explore how you can use those things that you have. For sure, what we need is that we have a common ground, and when we are talking about locations, when we're talking about assets, when we're talking about licenses, when we're talking about we can do capabilities, is something that we need to agree. I believe from the discussions that we have had this week and the report the Italo has made, etc., is that we are converging. Probably we will be in the position when we meet in Vancouver. Probably we will have something to show in progress, and there will be a new version or even several numbers ahead, because it looks like we are converging. Probably one of the things is this feature capability, this license entitlement, but I think that that is not that much complicated. And for us, what is important is take the base model, agree on the base model, and make this that is waiting for sure, align with the base model and move on. So just what comes next is that, well, the ALMO is the ALMO that is the document that is focused on the problem statement, the information model, etc. We intend to seek adoption once the terminology is settled and we can decide whether be sure that what we are naming is what we are naming inside the document is well aligned to what is the general understanding of the whole group. Take into account that the current version in Ivy is 0.0, but actually coming from OPSWOC is 11. So it's a reasonably mature document. It's pending this alignment, basically. With the other one, the MALMO, that is about the particular data models, the idea is to improve them. The models are there. That the point is that we have been very much focused in, let's say, well, let's call them sophisticated combination of entitlements. How you can be assured that you can provide a particular feature or build a service that depends on a set of features when you have different entitlements coming from different places and how they are combined, etc. I think that they're valuable, but I don't know. I mean, this is something that will require some refinement and deeper analysis, especially talking about examples, but I guess that in this context, examples are quite important. And that's all, unless you have any comments.
So do you think that some of the features work could fit here?
The feature work from whom?
Features, something like the number of VPNs that I can support, all those things, like I can support 10,000 VPNs, 2,000 are gone, I still have 8,000.
That's one of the
Because the
things.
life cycle makes me think of it.
Yeah, no, that's something that we have to discuss a little bit more, because there are certain capabilities. But let's try to distinguish a feature and a capability, or at least what I have in mind. Okay, it's not that even I should have to ask Marisol and the others to be sure if they share that. When we're talking about a feature, is something that you can do. I mean, it's something that you are entitled to do. You have the right of using it for setting up to 15,000 VPNs,
Okay.
because you have paid the owner of the technology for using that. That in a particular, in a certain, given a set of conditions, you can go up to the 15,000, or you have to have 1,000 because there are too much traffic, or there are some links down, or whatever. That would say could be a capability. I mean,
yep.
So we have to distinguish about what is.
It needs
What
some
is
thought.
inventory? The inventory matter is where you can get, and with the let's say the operational aspect, that is where you are, taking into account the circumstances. So I think, but they are related for sure.
Okay. Okay. Thank you.
Okay. Thank you.
Thank you.
And now the last presentation on energy saving management. No, we have a Marisol in the queue before that. Please, Marisol.
Yeah, so just a comment to the question Daniele and Camilo replied in the chat,
Marisol,
right?
we can't hear you very well. Can you speak a bit louder, please?
Can you hear me better now? Can you hear me better now?
Now, yes.
Now, yes. Okay. Yeah, Camilo replied in the chat earlier when he was explaining that a use case that we should cover clearly, and we are planning to enhance for the next release, right, to include more useful use cases. But he was referring the chat in the number of VPNs in the router is limited by a license. We should cover these kind of examples, and the data model can support it. But it will be good to include it as an example, practical example on it. But, this is the kind of use cases that we are looking for.
So it says the deck is shared, but it's not me. Let's try again. No, not share screen. Share slides. Okay.
Thank you. Good morning. My name is Qing Wu, and I want to introduce this young data model for energy saving management. So name listed here also is draft actually. And so why we propose this draft actually? As we know, the environment impact on telecommunication infrastructure, is not trivial. Energy efficiency became more and more important for the operator to operate their network. And actually, this energy efficiency not apply to the device level, but also network level. And we actually give an example like a tidal network. We will give a detail in the later slides. Actually, you can have various different energy saving methods to optimize energy efficiency. Currently, there's no standard mechanism to report and control power usage and energy consumption. And the goal of this draft is define young data model for power and energy management. So we can investigate the energy saving strategy and account for the total power received or provided by the entity or service and endpoint. And we can predicting entity reliability based on the power usage connected, from the network device. So the document status, this is still, initial version actually. And the first presented in this working group, actually, we made some change actually based on, author discussion. Actually, the first change is we add reference to, energy management requirements and framework, developed in the IETF 6988, IETF 7460. And also we add reference to the various parameters defined in the young data model, try to align the, terminology and parameter defined in the, energy management framework. And we try to distinct, energy saving capability from dynamic power and energy consumption parameter, but we model together in the same model. Actually, we just before actually somebody mentioned inventory, capability, this kind of concept. So this, something we actually try to model this and think is a very useful target to specific use cases. And we also, try to add a correlation with network topology. And so we already set up the GitHub and to track all the open issue in this draft. And if you have interest, and feel free to contribute with your comment and input. And so how to position this network energy saving model? Actually, we have, this kind of, SDN architecture, custom layer, and service orchestration layer, and network controller layer. This network controller can manage many devices in a domain. And so this energy saving model, is used on the northbound interface of network controller. So at the control level, we really can, provide energy consumption visibility. In addition, we can, evaluate the energy efficiency. So we can, to generate some energy efficiency strategy, populate this strategy or policy on the network device. In addition, we actually may rely on the network device. They have some energy saving capability, so we can enable this kind of energy saving capability. Leverage, for example, we can put unused resource into sleep mode. Actually, we also can rely on the device to automatically to wake up. And also, so for many devices, especially for some power module, they have some kind of heat dissipation mechanism. We can leverage it. So the idea is really, we can, consume less watts and spend more bits actually. So to achieve better, energy efficiency. And so this is our, energy saving model design. And you can see we define the single model energy saving management young data model. We actually extended from two young model. One is network inventory based model. The second is network topology young data model defined in the IETF 8345. For the, base model, we extend, with, a bunch of, stationary or static parameter. We, break it down into two categories. The first is, energy monitoring capability parameter. So we give the example, for example, energy saving mode. And so this represent, different energy consumption level. Second is energy saving method. Actually, so this can help you to know, which level you reached actually. The second category is energy provision parameter. So these usually for energy consumption monitoring, you may set some boundary for the power, for the current, for the voltage actually. So we may also need to set a boundary for the temperature. So we see this actually as a provision parameter, and both these two categories actually are stationary parameter. And in addition, we extend from the network topology young data models to try to augment with dynamic parameter. For example, we actually at a two level we actually introduce like current volts and or current power, these kind of dynamic parameter. We can better check with this to evaluate the energy consumption. So this is general model design. For the detail, actually, model structure, you can take a look at this. And so you can see the energy saving mode, energy saving method can be seen as capability. This we actually include in both node level at the nano topology model, but also at the node level in the nano inventory under the model. In addition, we actually introduced like a energy efficiency ratio, this kind of parameter, and so we can report this device level energy efficiency ratio. And actually, we also see try to establish a relationship between the energy saving mode and energy saving method. And also for power state, actually we model this actually in the component level, and power state can be broken down into four state with an off state, sleep state, and power and low power state, and power saving enable state. And here just give you a sense for how to clarify this energy saving method actually. So we can see actually we have three energy saving mode: with basic mode, standard mode, and deep mode. For energy saving base mode actually can support multiple energy saving methods. For example, unused high speed interface shutdown. This usually can be used in the place between two adjacent components. For example, between the optical module and physical module. And for unused port shutdown, this kind of method can be applied to the optical module. So you can leverage it like auto laser shutdown, this kind of mechanism. And for the unused board shutdown, this more focus on system level. So we can apply to the some kind of switch blade board, and also for standard mode, we give power module as an example. We can break down the power module into several sections. Each section has multiple power modules, so we can make some of these power module sleep, make some of power module awake actually. And for energy saving deep mode, actually we give example. We can have switch blade board in the between like SFU and SFU. Actually we can make a SFU like this kind of board to be awake, connect to all the nine board, and for another switch blade board to be sleep. And so we also support this unused channel shutdown. This usually can set up several channel between the port and the chip, and so we can make some channel sleep and dominant and make some awake. So just to give you a sense of this, how this energy saving method look like, how they can be used within the network device. Last, I just gave you an example, tied network energy saving. So we know this actually has already been documented in TVR use case draft. Actually, you can see the specific section. So this generally, you can see that the traffic, follows specific pattern. They can, rise or fall, at a specific time point. For example, they may, rise, at 12 o'clock or fall at the valley point, at 0 o'clock actually. So network equipment, so they have some kind of board or switch blade board. They can try to adapt to this kind of traffic change actually. So so we can actually make a some of within this network elements, make a what, at least one board to be enter into the sleep mode actually. When there's some configuration update or there's some alarm to be triggered actually, so this this board maybe we need to awake this kind of board and to make sure whether this event really affect any saving status. If it doesn't affect, we can make it sleep again. And if that's the effect, actually we can make it fall back to the initial state. But we actually allow some transition stage, allow some delay from the initial state to the transition state, so we can try to avoid frequent high frequency concurrent this kind of failure, or this or we can call this as energy saving status flapping. So that's a general idea how this can be used in this kind of specific use case. But we imagine actually there's more use cases, and this yeah, typically maybe in a campus network, maybe in a RAN network, and maybe in other network, if they follow this kind of network pattern actually. So that's all for the all concept, and yeah, I'm still here. Comments, input, question, yeah.
So I have a question. How it's not clear to me, how does this draft relate with the Tony's?
Yeah, that's a good question. Really, we think we should sync up with Tony's draft. I think he already presented in many working group, and I don't know how we can work together on this, because we have similar goal, try to address the same problem space, but we may have a little bit different solution proposed, and so definitely we need to get it together to discuss. Yeah.
Okay. And the second question is to Mahesh, which is already at the mic, which is we know that there is an ongoing activity dedicated to green networks, sustainability, etc. So how should we behave? Should we consider only the work that is purely related to inventory? Should we refrain to do any work on green networking, sustainability, etc.?
Yeah, so that's what I came up to the mic. So Rob and I have discussed this, and there is a work group forming BOF that we are targeting for 120 for anything that is green initiative. So at this point, I would suggest, I don't want to speak for Rob, but I think the plan is for work like this, it be deferred and wait for that work group to be formed. And certainly this is not in scope for IV.
Okay. But also stuff which is purely inventory related. I'm thinking, for example, I don't know, the power consumption of a given device. That is something that is inventory in the end. So do you expect the new working group to augment the inventory core model when it comes to inventory related stuff, or not? Or it will be completely decoupled from what you're doing?
So the green initiative, or at least looking at the power consumption model, I think the initial target, I don't have all the details in what the charter of the new working group is going to be, but it's going to be mostly around power management and power efficiency. So in that sense, is it an augmentation of the inventory model? That's a question that the work group can try to figure out. I don't have an opinion.
Okay. So you still have a couple of days to skip the line. I use them.
One day, a few hours. Yeah, so to back up what Mahesh is saying, and it's not it won't be my issue, it'll be yours to deal with effectively soon. So the aim there of why I was trying to suggest doing a BOF and actually getting a separate working group is to try and get the sort of power management related stuff, both the stats off and also any sort of control standardized quite quickly, because the sooner we can sort of make change in this area, the more chance that we can actually have some meaningful change to energy consumption. So as to where the work happens, I think that BOF and charter discussion will be a good place to decide that. I think it would be best for the work to happen probably within that new working group if it gets formed, with liaisons or discussions back, not liaisons, but discussions back to these working groups like IV and maybe OPSWG, wherever. But having one home for this stuff, I think, would help have a focus group for that work.
Yeah. So if if you're working on the charter, and if you could somewhere specify that everything that is inventory related should build on top of the inventory model rather than being something that is completely decoupled, probably that would be helpful. I don't know if it's possible from a process point of view.
Yes, I think you can roll whatever you like in the charter, but I haven't started writing a charter yet. I'm not sure it's going to be me writing the charter, so just to make that clear.
Kent. Yeah, I was also wondering about the applicability, but actually what I really want to say is I have a soft spot for this. I'm really happy to hear that there's a working group that might be spinning up to do it. 20 years ago, I filed a patent, was awarded a patent for power-based routing. And the whole idea was like certain data centers have solar panels and it's a sunny day, or they have a wind farm and it's a windy day. So you can actually calculate the route that would actually have the least, I guess the most renewable energy. To me, that actually seems more important than worrying about the power of like a specific device. Because if the entire data center is powered by renewable energy, that's actually more impactful and helpful to the environment. But again, for a different working group or BOF.
Yeah. But I agree with you. Actually, that's more a power metric, I would say, in something that you use in routing. One thing that to me fits more into the inventory space is, for example, not just how much power a given device is consuming, but where that power comes from. For example, you might have a device that consumes very little energy that comes from an high polluting source, or something else that consumes a little bit more, but it's completely renewable energy. So that, in my opinion, is inventory. What you were speaking about, it's more routing.
Actually, I have a quick question to our AD. Since we target to form a working group, do you think it makes sense to create a mailing list for this to have dedicated discussion, or where we should discuss for this kind of topic? Okay. Yeah.
You want to answer, Rob?
Well, can you say the question again? Because I can't hear. Yeah, say this question again.
Yeah, it seems that people have a lot of interest, and we target to create a working group. So whether we should create a dedicated mailing list for this.
Whether we should do what?
Yeah, request a mailing list.
Yes, mailing list. Yes, that will happen. Yeah.
Okay. Yeah. Thank you.
And we have Marisol in the queue.
Yeah, even we are out of time, right? I mentioned in the chat there is a site meeting tomorrow on power metrics, and we would like to discuss as well next steps with all the drafts that are around power metrics. I believe there is a big equivalent of this draft with Tony's as well as the PowerF that myself and other authors has been putting together. And there is in the practical use case that we are going to present tomorrow, Daniele, to answer your question, we are considering the inventory-based model. We are building on top of Almo because we consider the concept of asset, do not go to see if it's physical or virtual from that aspect, but we are considering the inventory, the IB work, right, that we are putting here in the base model.
Okay,
Thank
perfect.
you.
So we are successfully late once again. Thank you, everyone. A good lunch.
Thank you. Bye. So do you have the experience?